project is Project 15, Continuous Monitoring of CO2 Production During Yeast Fermentation. My name is Connor Wagner. We have Ben Goodson, Tim Sonnenberg, and Edward Martin over there. And our goal is to create a non-invasive remote sensor in order to monitor the CO2 production for home brewers in the United States.
The problem that our project was solving is the fact that for many home fermenters, this is not their day job, and monitoring the fermentation process is a pretty labor and time-intensive thing to do. Currently, you have to be physically present at your batch to watch the airlock produce bubbles, which are the off-gas of CO2 from the yeast. And with our sensor, we allow the user to simply put the sensor on top of the fermentation vessel and walk away and be able to monitor the batch from their phone anywhere they have Wi-Fi.
So to implement our design, we decided to use IR sensors as they're cheap and very reliable to use. We put them on either side of a stopper, and we were able to detect the bubbles as they come up and sense the bubble rate through a microcontroller. Then we can send that data to a server, which can then be seen through our smartphone application, and then we can also export data in an Excel spreadsheet format for documentation purposes.
Our hardest challenge was not procrastinating. So every demo is a 2-day delivery process, and if you try to do it last minute, like the night before, you're going to run into issues. And we learned that, for example, when we tried to do our beta demo, we had printed the case, but we didn't have everything in the case yet, and we hadn't accounted for how much space wires take up.
What we learned about project development is that you should definitely not procrastinate, which is one of the things Edward was touching on, but with a project with many members, it's very important to have very distinct coordination and make sure everyone is on the same page so that at the end, all the pieces of the puzzle can come together and truly make a final working product such as what we were able to come up with here.
Another challenge that we faced was getting this to run off of a battery for 2 weeks. All the current competing devices are corded and have to plug into the wall. And so figuring out how to run our infrared sensors, Wi-Fi transmission, and microcontroller off of a reasonably sized battery to fit into a case that can sit on top of a fermentation vessel, that was a tough challenge. And so our hardware reflects that, and that we're pretty proud that we came up with that solution.
Okay, so this is our product right here. First, I'll show you how it's done currently. So this is a home fermentation batch, and we're simulating the fermentation with an air pump right now. In reality, it would be CO2 coming through this airlock, and the home brewer would watch the airlock and count the bubbles as they come out to know how their batch is doing. And when the bubbles stop, the batch is done, of course. And this is our device. It completely automates the process. We've got a sensor here. We've got the bubbles channeled through a tube that's filled with water. And if you look over here at our block diagram, it explains how the sensors are working. The bubble passes through the sensors, it diffracts the light and causes a dip in our electrical signal. The microprocessor sees the dip and it talks to the server. It sends the data to the server. The server can send the data to an Excel spreadsheet where it can be plotted, and it can send notifications to the user. For example, if the growth rate is too low, if the growth rate is too high, or if it's done. And it can also send it to a smartphone application so the home brewer can monitor their brew from anywhere at any time. This is what the graph looks like in the end. So the blue line here is the CO2, and then the red lines are the error margins. And I mentioned the notifications earlier. What happens is if this blue dips below the red bar, then the growth rate is low, and it sends an alarm to the user that the growth rate is too low. And if it goes above, then the growth rate is too high. That means there's a contamination in the batch, and they get an alarm for that. And the home brewer will know that the batch is bad, and they can throw it away earlier rather than later. Another key thing about our product is it is priced at $35. Other products on the market are around $100 or $150, so it is a really inexpensive solution to this issue.